Hey everybody, we are talking about interest applications today, and hopefully you recognize these formulas. I know that I had this one on one of our tests for compound interest. So we've got simple interest and we've got compound interest, and if you'll notice, the compound interest has variables that are exponents or powers, but simple interest does not have a power at all. That's because simple interest follows a linear model and compound interest follows an exponential model. Okay, so let's go ahead and fill out what's here at the top. What is interest? It's money that is invested or loaned at a particular rate. So we could say invested, or it could be money that you get loaned to you, and at a particular rate. Simple interest, which is this formula here, follows a linear model. And the compound interest, which is the formula at the bottom, follows an exponential model. All right, so let's just practice plugging into these formulas. Okay. The first thing is on a standardized test, they will probably have the word simple when they are describing what kind of interest that you're doing. These particular ones don't say it, but you're looking for the keyword simple in order to know to use this formula. So we've got a student loan, has a 3% interest. We have borrowed a principal amount, that's the initial amount you borrow, for $5,000 for 9 years. So we're actually just going to plug into this, and we are going to find the final amount that you would pay on that loan. So they're using capital A for the final amount. The principal balance is the initial amount, and in this case they've borrowed $5,000. 1 plus, and now we're going to do rate times time. And remember, when your rate is expressed as a percentage, you've got to divide by 100 in order to put it in the formula. So we get 0.03. And then we're going to multiply by the time that you have this loan. They have this loan for 9 years. So I'm just going to put parentheses times 9 years. All right. And notice there's no power here, because this is a linear model, so we're just going to plug that right into our calculator. I'm going to plug it in exactly the way I see it. So it's 5,000, parentheses 1 plus, and then we're going to do 0.03 times 9. And notice that if you had a student loan for $5,000, you're going to end up paying $6,350. That's how a loan works. Banks are going to make money off of you. They're not just going to loan you money for free. So notice, if I do a subtraction here, the bank is making $1,350 off of you if you borrow $5,000 at 3%. So you will end up paying $6,350 for that loan. All right. This one is a little different, and I like it because it doesn't give you the initial amount. It actually gives you the final amount that you paid back. So let's go ahead and take a look at this. R is 4%, and we've got to divide that by 100. So your rate is 0.04. That's your R. Your time is 5 years. And then notice here, it says you paid the bank $1,800. Okay, this is not the principal balance. Y'all, this is the final amount. Okay, so it's a little different. This is the final amount. 1,800 goes on the other side of the equal sign. Okay. And notice it's asking how much did he initially borrow. That is your P. That is your principal amount. So we are actually looking for the P. So let's plug all of this in. So A is 1,800. They give that to us. That's on the other side of the equal sign. The principal balance we do not know, so we're going to leave that as a P. 1 plus, the rate is 0.04. And we're going to multiply that by the number of years that we had the loan, which is 5. All right. And now this is a little different. We're actually going to solve for P. So I'm going to go ahead and just simplify this part on the calculator and rewrite it. So I'm just going to simplify this. It's 1 plus 0.04 times 5. Hang on, let me do that. Mess that up. 1 plus 0.04 times 5. Okay, so that is 1.2. So let's rewrite this. We've got 1,800 equals, we can just do 1.2p instead of doing p times 1.2. And now if you'll notice, this is a one-step equation. I'm trying to solve for p, so I need to divide both sides by 1.2. So we're going to do 1,800 divided by 1.2. And the answer is 1,500. So let's talk about what that means. I like that we can get the answer, but let's understand what that means. It means that Theo initially borrowed $1,500, and it was at a 4% interest rate for 5 years. And so when he borrowed $1,500, he ended up owing $1,800, again, because the bank is going to make money off you. And in this situation, the bank made $300 off of Theo when he wanted to borrow the money. Okay? So again, simple interest. Okay? Here, I guess another way to say this is, how do we tell the difference when we're going to use the compound interest formula or we're going to use the simple interest formula? Well, if you remember some key words to know to use compound interest is the words semi-annually, annually, quarterly, monthly, weekly, daily, because these are the number of times the money is compounded in a time period. So that's your N. And if you're not seeing compounded weekly, compounded quarterly, compounded monthly, then you will also know it's just your simple interest formula. Okie dokie. So let's go ahead and do some compound interest, and let's talk about these different keywords. Okay. So compound interest is actually compounded more than once a year. And now you'll notice there's a new variable in here. It's an N, which is the number of times it's compounded in a year. So let's talk about these keywords. Well, annually is compounded once a year. Semi-annually would be twice a year. Quarterly, there's 4 quarters in a year. Monthly, 12 months in a year. Weekly, 52 weeks in a year. Daily, 365 days in a year. You're going to need to know these values. They will not be given to you. If it says compounded quarterly, you have to know that your N is going to be 4. If it says compounded monthly, you've got to know that your N is going to be 12. These will not be given to you. This formula may be given to you in the problem on a standardized test. Wouldn't hurt to know it, but I think it'll be given to you on a standardized test. Okay, so let's plug into these formulas and learn how to get them into the calculator. Okay, we've got a savings account that has interest rate of 3% compounded, and notice keyword here is semi-annually. Okay, so if we look back, that's telling us right there that N equals 2. And he invests $5,000. That's your principal amount or your initial amount, and time is 6. So let's plug into this. Okay. So he's initially investing $5,000 into savings. we've got 1 plus. We need our rate, and notice it's 3%. We divide that by 100 and we get 0.03. And we have to divide that by the number of times the interest is compounded. Since it's semi-annually, n is 2. And notice here we raise it to the n times t. Y'all, that's got to be in parentheses when you put that in your calculator. So n is 2. And we're going to multiply that. That is not a decimal. That means multiply times the amount of time that the money is going to be in savings. That's 6 years. All right. And to find out the final amount he would have in his savings account after 6 years, we're going to pop this in the calculator. If you already know this is a 12 and you're like, hey, I just want to put 12 in, that's fine. Otherwise, you've got to have that parenthesis there. Okay, so let's pop that in. $5,000, parentheses 1 plus, 0.03 divided by 2, and then we need a caret key, and we need to open a parenthesis and put in 2 times 6, and close your parenthesis. Okay, so after 6 years, he's going to have $5,978.09. All right. And let's try one more. Again, looking for some key words. Taylor applies for a loan with an interest rate of 4.2% compounded monthly. So notice this key phrase here, compounded monthly. That is letting you know that you're going to use the compound interest formula and that n is 12 in the formula. So got to be able to pick out these key phrases. All right, let's go ahead and convert our percent. It's 4.2. And need to get that percent off there, so we're going to divide by 100. That's going to move the decimal place back twice. So my R is 0.042. So let's start to plug in here. The loan was for $10,000. One plus. And my rate is 0.042. I've got to divide that because it is compounded monthly, so n would be 12. And again, the nt, we need to put that in a parenthesis. It's a power. N is 12. And that's going to be multiplied. That's not a decimal. That's multiplied by the number of years he has the loan. That's 4 years. And now we're going to put all this in the calculator to see how much she's going to pay back. So here we go. Okay, $10,000. 1 plus 0.042 divided by 12. And then we need a caret key. We're going to open another parenthesis. 12 times 4. $11,825. The 6 is going to round that up to 90 cents. So she's going to pay back $11,825.90. It's an 11. Okay. All right. Now you're going to practice these, and again, you've got to look for the key words. So when you get to your practice sheet, notice compounded weekly. That is telling you what your N is. Okay. Notice here, a bank loan has an interest rate. Rashid borrows $2,500 for 3 years. Notice it mentions nothing about being compounded in a particular way. It doesn't say compounded weekly. It doesn't say compounded monthly. So y'all, this is simple interest. You're going to use that first formula that's on the other side of your, that's on the previous sheet. Simple interest. Okay, sorry about that. I paused the video, so not sure what I said last. However, just keep your eye out on key phrases. Compounded weekly leads you to the second formula on our note sheet. And if it doesn't say how it's compounded, then that's going to be simple interest, and you would use the first formula on the sheet. Okay, you guys practice here and make sure you're writing out and plugging in your formulas. Let's not just write answers. And y'all have a great day.